Good morning, class. Today's topic is polymorphism. Poly means many. So polymorphism means one name and many forms. So this is one of the property of the object-oriented programming languages. It says that you can have the same function name with different implementations. It means, like, suppose I want to calculate the area of a circle, area of a rectangle, and area of a square. So whenever I pass the argument like radius, then it should be executing the implementation which we have defined for calculating the area of a circle. If I am passing the length and breadth, then it should be executing that implementation which we have defined for calculating the area of a rectangle, and so on. So it means it should be able to identify that which function had to be implemented depending on the kind of argument I am sending to that function. So the name will be same, that is area, which is the function name, will be same for calculating the area of a rectangle as well as the circle and as well as the square, and so on. So polymorphism can be done at two different times. One is the compile time and another is the runtime. So in compile time, the examples are operator overloading and function overloading, and in the runtime we make use of virtual functions for achieving the runtime polymorphism. Now let us see what is function overloading. So process of using two or more functions with the same name but differing in the signature is called function overloading. Now what do I mean by signature? Signature means I can change the number of arguments which we are passing to the functions, or I can change the data type of the arguments. The return type has got no impact on the function overloading. So for example, suppose I am making one function area, and in that I am passing only one argument. Let us say the radius. So circle, for calculating the area of a circle, I will have to pass one argument, and that is radius. So it has this will be executed whenever I call the function area with only one argument. And suppose I want to calculate the area of a rectangle, then I will require two arguments, length and breadth. So whenever I pass two arguments, then it will identify that we have to execute the implementation which is having two arguments as input. So but natural, it will be calculating the area of a rectangle, and so on. So in function overloading, function call determines which function definition will be executed, because in the function call we are passing the arguments. So we will change the number of arguments or the data type of the argument so that it can choose the correct function for execution. Advantage of this is to perform same operation on different data types without having the need to use separate names for each version. So it is but natural that we will be more comfortable if the function name is area and we want to calculate the area of a rectangle or circle or square or any other thing. So we will be more comfortable if we name the function name as area for all the different categories. So this power is being provided by the function overloading mechanism of the OOPM. So let us now look one example. So here we have defined one class. Class name is print data. Then we have defined three different functions. All the names of the function is print. Return type is void in all the three. The only difference which we have done is in the data type of the argument. All are having only one single argument, but the data type is different. The first function, void print integer I. Here we are passing the integer as the argument, and here we are printing. We have written the cout statement as printing integer and then I. In the second version, we are passing one argument but of type double. In the third function, we are passing again one argument but of type character pointer. It means it's a string. Now let us look at the main function. So in the main function, we define one object of type print data. Print data is the class name, and PD is our object of type print data. Now we use this PD to access the functions, and as we have already discussed that whatever variables and functions are present in the public section of the class can be accessed using the object name and the dot operator inside the main. So all these print functions have been defined in the public section of the print data class, so we can access them using the object, namely PD. So PD dot print, and then we have passed a single argument, and that is integer, that is 5. So it will pick the first function from this class and it will print the integer value. Next, we have passed the argument pd.print and 500.263. Now this is the decimal part, so it will be accessing the second function which has got the argument of type FF. So this will access the second function and the output will be printing float and then 500.263. In the third, we have called pd.print and then we have passed one string. So this string will be choosing the function which has got the argument as character pointer C. So character pointer C can accept any array of characters or a string. So this function will be executed and the output will be printing character hello C++. So this is example of function overloading, which is the compile time implementation of the polymorphism. Second example for compile time is operator overloading. Like we are overloading the functions, we can overload the operators also. Suppose now it is a type of polymorphism in which the operator is overloaded to give user defined meaning to it. Overloaded operator is used to perform operation on user defined data type. For example, plus operator can be overloaded to perform addition on various data types, like for integers as well as for string concatenation, etc. Now this is a normal functionality of the plus operator, that whenever we provide two arguments, two integer value or two float value or any numeric data, then it will simply add them. Like suppose we have given one example, c equal to 3 plus 4. So this plus operator has got 3 and 4 on left and right hand side. Since this is a binary operator, so it will require two operands. So here two operands are 3 and 4. So they will be added and the answer or the result will be stored in the C. Now what will happen if we place two strings in place of any numeric value? So here we have written S equal to Ankit plus Fadia. Now in the normal scenario, this will not be concatenated until and unless we overload the operator plus. So there is a well-defined procedure and syntax for overloading the operators like plus, minus, multiplication, division. Anything can be overloaded by following that procedure. So suppose we have overloaded the plus operator, then it will be able to concatenate the string. So if we are passing two strings in the plus operator, then it will concatenate them, and if we are passing the numeric value, then it will simply add them. This is an example of the operator overloading. So we are overloading the plus operator. Now restrictions on operator overloading: precedence and associativity of an operator cannot be changed. Next, number of operands cannot be changed, that is unary operator remains unary, like plus plus I. So plus plus I will contain only one argument, so we cannot pass two arguments in it. Binary remains binary, it means binary operator, like we have discussed plus operator, it is a binary operator, so it will require two operands, so we cannot change it like we are passing three arguments or we are passing only single argument. It is not possible. So the basic the number of operands will be cannot be changed. No new operators can be created. Only existing operators can be overloaded. This is the next restriction. Then cannot redefine the meaning of a procedure. You cannot change how integers are added. So the basic functionality of any operator cannot be changed. It is already predefined, so it will work like that only. By overloading, we are simply adding the we are giving the additional facility to the user for doing multiple tasks with the help of the same operator. So these two, operator overloading and function overloading, are the compile time polymorphism, and the runtime polymorphism is implemented using with the help of the virtual functions. Now, it is used for achieving the runtime polymorphism. A virtual function is a member function that you expect to be redefined in the derived classes. So normally the virtual functions are defined first of all in the parent class, and in the derived class again we redefine this function in the child class. Now at the runtime we decide that which version we need to call, whether the parent class version or the child class version. So name will be same. The only thing is whatever function we are writing in the parent class will be preceded by the keyword virtual. It will notify the compiler that it is a virtual function, so it will be redefined in the child class again, and at the runtime it will be we will decide that which version of the function had to be called, the base class version or the child class version. So that is all for today. Thank you.